My name is Oscar Agertz, and this is Mattias Wallergård. This is Simon Holk, and me and Mattias are thread leaders of data thread 2, and the title is in principle, visualizing the universe. But we went with this title today instead because we're going to show you some of our work on virtual reality together with the universe and maybe a bit of understanding as well. Yeah. And this is work done together with all of these people here as well. Some of you are in the audience. We have, I think, Henrik sitting there in the back. And Henrik and Simon have been very important for the sort of software development that we've been doing for this virtual reality application. Okay, so, the movie we've been looking at here for a while is an artist impression of what it would look like to fly through the Milky Way galaxy, close to our nearest neighbors, the Andromeda and M33, and here ending up at the end at one of the most nearby galaxy clusters. And I will get back to sort of maybe things we would like to do with real research data in the future. Okay, so the mission statement for this thread was basically this here. So visualization and mining of large and complex data sets is an important challenge in many scientific disciplines. And we will utilize expertise within the data team to develop techniques that will enable researchers to visualize and interact with high-dimensional data. And the hope was then also this would actually have applications across different research fields, including archaeology, astrophysics, chemistry, and medicine. Okay? But two of the specific examples or applications that we were targeting were relevant for galactic astrophysics, so that's my field, so surprise. So that would be supercomputer simulations of galaxy formation and the Milky Way galaxy. Okay? And specifically how we can learn more about these, explore these sort of things using virtual reality technology, which we will get to at the, in 10 or 15 minutes or so. And, when we were doing this, we always kept this sort of question in mind, right? Can better, more intuitive visualization techniques help us make new discoveries? Okay? And as Anders has been telling us, this is something, the answer is probably yes, but, it's not really obvious how that should be done or how to best do this, right? Okay, so the first example will then be supercomputer simulations of galaxy formation. So this is my research field. Okay, here you see a movie, of a computer simulation. So this simulation takes basically a year to run on hundreds of CPU cores. This is a movie done on the fly as we were computing this. Okay, so we cannot go in and change the angle or whatever we are doing here. We have this movie. That's the visualization we have after a year. Okay, but what you see here is basically large-scale view of the cosmos. Each of these little points here is essentially a galaxy. Okay, and we are, and you can see that the galaxies are building up into larger and larger structures as they are merging together. Here we have a little spiral galaxy forming here. This will, after probably 14 billion years of evolution, this will look like the Milky Way, we hope. Okay? So we do these models because we want to understand galaxy formation. We understand the physics of galaxy formation, but it's very, it's very complex data. So it's high dimensional. First of all, we have several spatial dimensions, and we have time. We have multiple species, so gas that end up forming stars, right? Once it's cooled down into some dense configuration. We have dark matter, which I don't show here. I only show the gas. Okay? Dark matter is important for keeping galaxies together, or holding them together. And then, of course, all these species have different metadata. Right? Stars have chemistry, velocities, and all these things. So it's a lot of data to treat. And it's complex. So actually visualizing, and I would say also playing with data, for me at least, leads to often to improve intuition of what is going on. And we hope that can lead to new discoveries. Okay? So when I work a lot in this field, we do analyze these in a very robust way. We are looking for the physics of galaxy formation to establish a theory of galaxy formation, but it helps a lot to do these kind of visualizations, right? And to look into details of what happens when this galaxy here is merging with this one, for example. And I will show you a very concrete example of a visualization-driven discovery. So this is close to what Anders was saying about exploration, right? You want to explore the data and find a mechanism, okay? So if we take a patch of this simulation I showed you before, something like that, and we look at the dark matter, this elusive particle, we don't know what it is, but in the simulations, it will look something like this, okay? So the large-scale view of the universe, each little point here can maybe host a galaxy. We think this point here is probably where a galaxy like the Milky Way is forming, okay? So we switch view now to looking at where the gas is. So the gas is where, basically the atoms are in the universe. And, in these points here, right, we think stars are forming. And most of the stars are forming here in the very center. It starts to look like a little disky thing here, right? And when we did this, we discovered how extremely filamentary this process is, right? And we went even further, okay? We wanted to sort of understand more what is the physics of this assembly process. So we took this little piece here, and this is us playing with the data, right? So we started using different color maps for different quantities. So temperature, we called that red. Density in blue, okay? And then we took green was basically the heavy elements. So elements heavier than helium that forms, inside of stars and then is ejected, okay? In supernovae or whatever. So if you combine this, you get this kind of weird picture, okay? So, and it becomes immediately clear what is happening, more or less. So we have here the galaxy forming in the middle, and we have around it, in red, here we have a corona of hot, low-density gas. Okay? So if it's red, it has to be low density and has to be very hot. Okay? Millions of Kelvin. Okay? And some of this gas makes it onto the galaxy. But we also found a new mode, right? A dominant mode of galaxy formation here, which is these cold streams. Okay? So if you're blue here, it means you're dense and cold. Right? And also, there's not a lot of green in here, right? So it means it's pristine. It hasn't been touched by any heavy elements, right? So it's coming from large scales and all the way in and assembles a galaxy. Right? So this is just a little example of, when you play with the data, you discover these things, and of course after this you quantify how much mass is flowing into these streams, what's the angular momentum of this, right? But the first step was taken by visualizing the data. And the next step that we have been discussing a lot here, also with Mattias and others, is then what can we do with the Gaia data? And Anders already introduced the Gaia mission. Okay, so this is the satellite that was launched in 2013, and we just had a data release in 2016. With some of the sky positions and magnitudes. In a few weeks or a month and a half, we will actually get data release 2, which will give us sky positions. And thanks to having parallel access as well, we will actually be able to get a 3D map of more than 1 billion stars in the Milky Way galaxy. Okay? So it's a fantastic time to do this. We will get a three-dimensional map of the Milky Way's more brighter stars. Okay? So it's a treasure trove for unraveling the formation history of the galaxy. And it's worth mentioning that Gaia is very tightly connected to Lund, right? So Gaia was thought up more or less by Professor Lennart Lindegren, who's a professor here in the department. And so this is something we would like to explore more, okay? And where we think virtual reality can be one of those important or interesting technologies to use. So keeping in mind this question, right? Can better, more intuitive visualization techniques help us make new discoveries? One example of what we could possibly find if we explore this in a spatial kind of way would be faint stellar streams, so cosmic leftovers from galaxy assembly. So when the galaxy formed, as you saw in this movie, you have all these little small satellites going around. Okay? And when they interact with larger galaxies, they deposit stars as well. Okay? So they have these streams of stars wrapping around galaxies. All right? And we have lots of observational evidence for this, right? So if you look at the northern sky, here you can see, if you squint a bit, you see a lot of these streaks on the sky, right? And there are probably many more, of course, out there than we see here. And developing stream finders is not an easy task. So, for example, one way to use visualization techniques, or one thing that could come out of that would be to sort of detect streams with basically the human vision, more or less, right? And we want to explore this for sure. So yes, so the next step then is virtual reality. So we want to stick the Gaia data into a VR framework and see basically what we get, right? And to introduce that will be Mattias, okay, in the next part of the talk, right? I will leave this up for 2 hours too.
Thank you. And please observe Professor Melvin Davis throwing around Saturnus and Jupiter here, it's, if you wondered. All right. Virtual reality is this concept popping up constantly here. What is actually virtual reality? Let's take a historical look back in time and start with, this is actually 50 years ago, almost on the day. This is Professor Ivan Sutherland experimenting with what is usually referred to as the first virtual reality system called Sword of Damocles, because the damn thing was so heavy that the people were afraid to get it in the head and die. Let's jump to the 90s. This, some of you who are old enough to remember, maybe remember the super hype of the 90s of virtual reality. Virtual reality was promoted as a computer-generated world where everything would be just amazing. And some of you might even have seen the movie Lawn Mover Man, where this concept was even further enhanced by Hollywood. And it turned out it was all just a bunch of crap. So jump 10 years into the future, and now it's big, expensive, hard to maintain systems. This is actually the cave we have here in Lund, and another example, immersive workbench there to the right. This is very typical for the beginning of the 21st century. But now we're actually entering in a mature phase where this can be done with virtual reality. This is actually the way it feels to use virtual reality. And if you don't believe me, you can actually try later here if we make it work, Simon. Yeah. No pressure, no pressure. So why virtual reality in the first place? One really great thing with the Pufendorf theme is that it has gotten us a lot of time to actually sit down and take a critical look at virtual reality, because maybe we came in with a little bit of a, yeah, VR, yeah, cool, just stuff in a lot of data. So are we using VR just because we can? There's a lot of cool hardware and, yeah, toys, really, out there that stimulate all sorts of senses, and they basically don't cost that much anymore. This thing here, for example, you can get it for about 400 euros. So prices are sinking very, very quickly, and there's enormous amount of money being invested in developing new VR hardware and software. Or should we use VR because we should? This is an example of that I will come back to later, with 3-dimensional data from a research group here in Lund. That turned out they really, really needed a new way to look at their data, because this was too inefficient. It was really diminishing their ability to do new discoveries. So they needed something new. And when I think of virtual reality for data visualization and data analysis, I really like to think about what is called embodied cognition, which is quite a new theory in cognitive science. And there are experts in this in the audience, so I'm not going to dig too deep into this. But basically, what it says is that we're not just thinking with our brains, we're thinking with the whole body. That's basically the core of this theory. And connected with VR, this is a really nice match, actually. And I wanted to show you this little movie here as an example of this. When the structure of DNA was discovered by Watson and Crick 60 years ago, it was actually very much a matter of exploring, using their whole perception, their trying different things. And what Watson here actually shows us here is how they got so desperate because they really couldn't crack the code to the DNA molecule. So they started to cut out pieces of paper and just place them in 3D space, turned them and twisted and played around with it, played, as Oscar said before, until they found something that actually was coherent with the theory. So what we see right now is actually, I hate the word paradigm shift, but I'm going to say it anyway. It's a paradigm shift from desktop computing to immersive computing. So this is the first personal computer with a desktop user interface. And here we have basically an operating system that you walk into. So it's an operating system that is represented by a building, and you use your whole body, your whole perceptual apparatus if you want to do things in there. So a couple of examples of what we do here in Lund. These two guys, Shamit Sunei and Stefan Lang, are doing something really, really nice, and I hope this is going to work. Yeah. So this is actually an old video. I have no idea what they're up to right now, but it shows how they are analyzing their data. So this is what is called single-cell gene expression data. I have no idea what that is, but it's a lot of points in 3D space that they can analyze in all sorts of ways. So this is just an example of what can be done. So they really, really push the limit of VR to be able to analyze their data in a completely new way. And here comes these two crazy guys, Oscar and me. The Gaia VR project that hopefully can be demoed in a little while. We'll see. Otherwise, we just you can try it on when we have lunch later. And examples of challenges we're running into here is, for example, how do we actually handle these billions of data points in real time, stuff that Anders has talked about a lot already. And how should we actually visualize it to the user? If we visualize all the, 100 billion stars at the same time, it just becomes like a big white ball, basically. How should we interact with it? It's a lot of user interface design going on here. And how can we design for efficient collaboration? Maybe a research team in Lund collaborate with a research team in, I don't know, completely different part of the world, acting on the same data in real time. Then we're actually working a bit with what we call a virtual reality framework. And it's Stefan Lindgren and Henrik Garde working a lot with this. And basically, I see it as like a black box. You put in a lot of data on one end, and it spits out a 3D model with a user interface. And you have some knobs you can turn to get exactly what you want. Right, Stefan? Yeah, no, jokes apart. This is something that we just started on, but this image here shows how we imagine it to work, basically. It's a way to make it easier for researchers to transform their data into something that can actually interact with in a virtual reality application. So finally, I just wanted to say something about where are we actually heading. And I think it's very interesting to compare where we are right now with VR to where we were, like, what was it, 70 years ago almost, when there was like the computer. You queued up to get access to the computer. And it's a little bit like that today, virtual reality lab. You need to get access to the hardware, to the know-how, to the software, and so on. But what we're seeing right now is, I think, very interesting because all this is changing right now. So just like with the computers that moved into our homes in the beginning of the 80s, we're starting to see the same thing with virtual reality right now. People buy this HTC Vive and just do crazy stuff at home, which is great. There's a generation of kids growing up with this technology. But in the future then, if we look at what happened to computing, I mean, it became ubiquitous. Everybody's going around with, I don't know how many computers. And if you look at VR, probably the same thing is going to happen there. It's so part of everyday life that we don't even think about it. Of course, we use VR for everything. The virtual will be just as natural as the real, if you want. It's almost a bit scary to think about it, but yeah. All right. I think that's the last slide. And did you just make it work? Yes. Incredible timing. Amazing. I've actually been seeing Simon here doing updates and trying to get contact with the Bluetooth devices.
Yeah.
See sweat pearls coming out.
Okay, so you need this, right?
Yes, and I hope it will work.
This is the big moment. We haven't tried this before, so...
Where's you had the adapter? Oh no, sorry, yeah, you did. Okay, yeah. Let's do it this way, so we can record. Okay. Okay, let's go see.
So we will try to do a sort of narrative here, and Simon is just playing around with the Milky Way.
So we should say, okay, so obviously we have, a month and a half until we will have, the Gaia data to play with. So this is now a computer simulation I've done of a galaxy. Okay, so I'll entertain while you do that. Okay, but yeah, and of course we haven't solved the overall billion particle issue, right? We cannot fit a billion particles and other metadata in memory yet. We have some ideas how to do this in a seamless way, how to scale things, only show the things that you are, using octree structures and these kind of things. But this for now is a demo of a galaxy that will look and feel like the Milky Way, okay? So of course, to actually understand or sort of appreciate this, you have to try this. That's why we have a lunch break. So please go up and try this one, okay? And for now, so Simon has loaded something in. So try to sort of just look around a bit and show, before we look at the controllers, Simon, we can just show what is the data. So now we are a bit zoomed in. Can you zoom out a bit and see what we are dealing with here? Okay, so it starts to look like a galaxy, right? So it's a spiral structure, and it's colored in a funky way. So for this demo, we just have positions of stars essentially, and we have one variable to plot. Okay, so that's the age of the stars. Okay, so we have a few hundred millions of years of star formation in this galaxy, and so you can here see some of these. The younger stars are sort of clustered more, while the other ones are spread out. So I don't know what we're looking out into deep space now. And, okay, so yeah, you're basically standing on the galaxy, right? Is that?
Yes.
Yeah. So we should say that this specific headset is here we have no trackers, right? So if you buy an HTC Vive or these kind of things, then we'll have these lighthouses tracking the movement. So this is probably okay. But it's not as good tracking, as far as I understand, right? Than compared to these other things like Oculus Rift or HTC Vive. So, okay, so.
Oh no! How do I get out of here? Oh, I have to take it off.
Is there any? Should we accept those or ignore?
Ignore.
Okay, do you wanna?
Om jag hittar en muspekare, lättare sagt än gjort.
Jag måste trycka på Windows Y.
Windows Y.
Tror jag startar upp det.
Right. Okay.
Yeah, does it work now? Yeah.
Yes.
Okay, so I guess when you have this in a more of a room setting, you can actually just you can position the galaxy we want and just walk around it, right? And I guess what you can do now is you can lift the galaxy up with your right hand, right? Yes. And just hold it in front of you, right? Okay. Okay, so it's a little wobbly. Okay, so I guess now you're looking at one of these star clusters that's formed, right? So if you just leave it there, right? I guess you can just walk, go up and to the cluster and have a sneak peek right in front of it, yeah. So I think this is, whenever you're trying this out yourself, it becomes really apparent how your brain somehow discerns three-dimensional structure, right? I mean, it's amazing. You can really see little features inside this cluster and in the spiral arms of the galaxy. But the thing I guess we wanted to do, right, is to now use this as to analyze things in real time. Okay. So, for example, now this is now showing all of the stars here. So I guess what you have now in your left hand is a little toolbox, right? A little iPad. So what do you have here? Maybe you can tell us what your...
Yes, we have the grip button. It's the thing that lets you grab the elastic, and you have like a box selection tool that I can show now, and it's let you select which part you want to see, so you can now only see this part, and you have a measure tool, and
Maybe we can measure the size of the star cluster there. Yeah, as a demo. Yeah.
let's change. So right now the units are not like too accurate.
Yeah, it's a small clear.
Maybe I should make the
Florent, is that okay? Yeah, yeah. So Florent is a star cluster expert, so as well. So it's okay. Okay. I guess already now we can see. Okay, so already now we can see, like, it's difficult, of course, when you're filming this, right? Because for you it's natural, but for us it's every little head movement is an irritation to us, right? But but you can see here, of course, you have multiple. Maybe you have some extended star formation in this case, right? Because you have different colors in here. And this is something you can analyze, right? So, well, okay, maybe you want to show the.
Yes.
So you can get, immediately get histograms of. So this is now the stellar age, right? So, and this little plot you can, resize it, reshape it in front of you, right? And just keep your eye on this plot, right, so we can see what you're looking at, right? What it shows. Okay? So we have the star cluster, we have this thing here. So we have age distribution then, right? So you have just immediately made a histogram, and there seems there's like a peak here of star formation, right? So likely the star cluster formed quite rapidly, but it could also be that we have some junk, right? There's some extended star formation here going on. So that's very interesting. So then we would like to know, where are those stars, right? So yes, now what Simon did, he actually interacted with the plot, right, or the histogram, and he selected a little bin there of the stars, and you can see where they are, right? If you then of course look at the star cluster, so you can select those, and then you can just basically grab the star cluster, look at it in front of your eyes, okay? See where these things are. So we don't really see. Yeah.
Should I?
Yeah. So pick something else there, right? So, yeah. So you can you can just select a little bit of that. So, is that in the star cluster or outside? That's something I would like to know, for example. Right? Okay. So yeah, just look at. Yeah. Okay. So that's it. Yeah. So now look at something on the left there instead, right? Pick something that formed much earlier. Okay, like that. Yeah. So that looks like maybe that was the core of a star cluster. So there's some extended star formation. Okay. So this is just a little example, right, of the kind of, this is just with one variable that we have, right? And now you can sort the data and sort of play around with it, right? You can pick different ages, and you can imagine doing this, in terms of chemistry of the stars and all these other things. And of course, when you discover something, I guess you can actually add a little Postit notes, right? So let's say we are interested in this. Okay, okay, I found these sort of young stars in the star cluster, or the older stars, to be honest, actually, of these star clusters. So what do we do then? Okay, we can select. We can add a little thing here, and the hope then is, then you can actually, in the end, you can write something, and what it will be then, you can save this setting, right? Export it, and then I can send it to my colleague Florent, and he will say, then he will interpret it for me later on, right? Okay. So the hope is then, that you can actually have this sort of way of interacting with the data with other people as well. I don't know if you want to say something also about multi-user, features. What's done in VR, and this is something where it would be very useful, right? If you are several people at the same time looking at this.
And the interesting thing is that the tool that we used here, which is called Unity, is a game development tool, and games are often played online. So all the necessary libraries we need for implementing collaboration tools are actually there, without us having to do that much, really. And the example I showed you before with the gene expression study that is being done, they have already implemented a quite nice collaboration tool. Not sure how much they're using it already, but the potential definitely is huge to work in distributed teams. And I understand that the Gaia data research is very distributed over Europe.
Yeah, it's a European-wide effort for sure.
Yeah. I also would like to say something about the accessibility of this technology. This is called a Windows Mixed Reality set, and you can get one of these for €400, like I said before. And you need a decent computer with a relatively good graphics card, but the prices are sinking very rapidly right now. So starting to work with this is, I mean, you need a really good student and a little bit of money to give him, and then you can do amazing stuff, really. So it's not something that is locked into big, expensive, strange, dark labs anymore. This stuff is coming out into our living rooms and in our offices as we're speaking.
Yeah, I have one more slide to end this with, right? Okay, so if you're interested in this, and I think this needs to be tried out, right? I think, if you want to see how it is to explore the data, it doesn't do it justice on the screen.
Yeah, exactly.
And
you really need to try it out.
And, finally, of course, if you are interested in, let's see here. Okay, final thing. Okay, so if you're a PhD student interested in these things, I would urge you to go to the Compute webpage. I'm sure you've already been there 10 times today already, but go there again and click courses. And so now we are doing a course starting in a few weeks on virtual reality in computational research. And it's very timely because just yesterday we built a virtual reality lab in the basement of the Astronomy Building. Here's Florent building it for me. And here is me taking a photo of Florent using it, right? So we have an in-house, set up like this with actually nice trackers and everything. So we tried this out yesterday. It works, it beautifully. We have a dedicated space here. So we'll use this as a part of the course. So if you want to know more about this, talk to me today, or check out the webpage as well. Okay. Thanks.
Thank you, Oscar, Mattias, and Simon. Questions? Where do we have? Yeah.
So I have questions regarding the visualization of the universe. I have worked on reconstruction of a lunar topography, and I know what it is right now because we can get from the satellite images or the point clouds, the elevation models. But I'm more curious to reconstruct what it was before, and then it's like when you visualize the universe, it's not like from right now to the future, right? You should also be able to visualize what it was, or at the very original state. So, but I have a problem. It's like I can't convince people my model of the lunar topography long time ago was correct, because I have no data to validate the model. So, do you have any suggestion about this, or how you visualize the universe a long time ago?
I think this is a good question. It's very topic dependent, right? So in our case, if we now get the Gaia data to work as we wanted to do, right? And let's say we use visualization to find some structure, right? Yeah. Then we have to have a model for where does that structure come from, right? Let's say it has a very particular chemistry of some stars. We discover that using visualization. Then that doesn't mean we automatically have the history of the galaxy, right? Then we have to map it onto a model to explain that, right? So it's not for free. So what we're showing here is basically static snapshots from observations. Of course, if you have simulations, we have the time component for free, right? But in your case, I wouldn't know in detail how you would then go back to sort of recreate the history of the lunar surface, right? But at least you hope to discover things that would lead to will be some historical or evidence, right, for some events. Okay. But we can talk more later about this if you want to, over lunch.
Thank you.
Are these hardwares and softwares compatible with Linux?
Simon. It is, right? Yeah.
I'd say so.
Limited support, I think.
Limited support means no.
I don't know how it is now because I haven't tried it, but before it was really hard to get it working on Linux. But I know that like Valve that is behind Steam VR likes Linux, so I don't know if they have implemented it.
I think many of us work on Linux platforms, so we may have difficulty with that.
Yeah. So what often would happen then? Let's say for this course, right? I have a Mac, and you can't run this stuff on a Mac, right? So what you develop things in your Unity engine, right? And then you have a little project, and you stick it into the computer that supports this. Right? So that's probably the workflow you have to have. Yeah.
Micro, it's Anders Ynnerman. If you wait for the microphone, please, Anders, so we can record what the
Yeah, so it's really two different questions. I mean, the first one deals with the limitations that you have in software like Unity. I mean, if you want to do something that scales up in terms of data, Unity may not provide you with the infrastructure you need to be able to do that. If you're going to have multi-res, if you're going to have outer core rendering, all of those things that you need to address the big data. So I was wondering how you're thinking about it, if you're going to leave Unity behind and do something else, or that's one question. The other one deals more with, you know, I've been around in three waves of VR, and I've always had the problem with. I admit the fact that the quality is better now than it was the last time around, but at least for me personally, I still get VR sickness. I mean, we're still limited by all the perception things that are still wrong. Just having eye separation is not a good depth cue. You get a headache after a while. And also in terms, if you want to do immersive work in terms of analyzing data, ergonomic issues, do you really want to stand and interact with the data the way that you do there? I still have all these. I'm excited about the possibilities that immersive data analysis provides you with, but I'm still concerned about all those issues that are still there. And what are your thoughts on that?
I guess.
Should we start with the first question? Sure. Or yeah? I think I throw the ball at Henrik, actually. Because you are the one that has most hands-on experience of actually trying to scale things up in Unity.
So
What?
If Anders gives Anders Henrik.
Thank you. Yes, I was a bit concerned when I listened to Anders' talk here, because what we saw was so amazing compared to ours. But then at the end, I regained a positive view on our projects, because we are playing with simpler blocks in our game, and I think that's our force, because we want to share this with any researchers, also with people without a programming background, to put in their data, play around with changing just a few lines in the code, and then it fits into their data set. I think that's a point. And if they succeed and find something, they'll ask Anders to visualize this in a larger scale with more data and more fidelity. I think that's the answer.
Yeah, I would agree with that as well. I mean, this is, in the end of the day, at the moment, it's a fancy particle loader, right, for kind of, you know, your everyday research. And of course, I would say, I guess it doesn't really scale to any of the big data we wanted to go at some point. But yeah, they have different applications, I guess, in the end. So even though we would like to merge these things, maybe we cannot with Unity. So. Yeah.
And to move on to the second question, I think the huge difference between the 80s, 90s VR wave and the VR wave we're inside right now is that back then it was not a consumer product, not even close to a consumer product. In fact, the only example of VR in the kind of head-mounted display VR that we're using here that could be used in Sweden in the 90s was a system in Stockholm that cost 500,000 kronor. And I mean, I wouldn't call it a mass consumer product, really. But now, actually, as I said, this is starting to come into people's living rooms. And that forces the industry to really address these issues. And if you look at, I mean, the most important thing to avoid cyber sickness, for example, is, two of the most important things is the tracking and pixel persistence. And both of these things the quality is increasing so quickly right now. For example, with the HTC Vive, you have a precision under 1 millimeter. And we're starting to see 4K screens in the head-mounted displays that are starting to appear in the market right now. So I think the ergonomic part is actually, it's a problem that we have right now, but in a couple of years it will really start to diminish. That's what I believe.
Just a quick comment.
Yeah.
We can talk more about it, but Henry Fuchs, who's one of the big grandfathers of VR, he gave a talk last year on basically saying why VR is not going to work this time either. And he systematically went through all of those perception issues that you have in terms of latency, and the conclusion is you're still an order of magnitude off. Right? It's a lot better now than it was last time, but you're still an order of magnitude away from being in a position when you can avoid all of those things. And you might want to need light field displays. You want to replace the stereoscopic viewing with light fields instead, which is still a long ways away. So, but I agree, it's a lot better. And it shows promise, but you still have my question about the ergonomic issues in terms of production work. If you're an analyst, if you're a data scientist, do you really want to stand up and hold a wand for 8 hours a day to do your work? I mean, I was one of the test subjects for this on a project in Utah when they did tracing of neurons in the brain, right? And you stand there for an hour and you do neuron tracing in VR, and you get pretty tired, right? And I think this is an issue that we need to think about when we do implement these things.
Of course.
And we
and there's
provide
a
the
lot
tools.
of research going on right now in 3D user interface design. And you can't have these kind of gestures where you work with a hand over the shoulder, for example. That is of course a no-brainer. So I agree. There's a lot of work to be done to invent new, more efficient, more ergonomic interaction techniques for this. Definitely. I don't see that anybody would want to work with this 8 hours per day, and that's not the way we see it either. As we tried to communicate earlier, is that this is one tool of several tools. So it's not the tool, it's a tool. That's the way we see it.
We don't want to pour everything into this, right? I mean, this is how we work now. Is anyway that visualization step where we sit together and in front of a screen that they could be augmented a bit in this way.
Yeah.
I think we also talked with Henrik about these things of having a maybe you have a visor of some sort. You flip down, you interact with the data, you flip it back up, and then you continue, right? So being inside of this world in 8 hours, I would never do that. I would refuse to do this.
Plus, there is a really fast development in alternative modalities like eye tracking, for example. And we have, I think, at least someone here that is around eye tracking. And there I see huge potential to increase the efficiency and the ergonomics of the interaction techniques and make the tools faster to work with and so on.
Sure. I mean, don't misunderstand me. I'm just as excited as you are about the possibilities, but I think there's a lot of research that remains to be done before you can push it out in production.
We're very happy that there's a lot of research to be done.
And and even to the extent that open space is also supporting, and it's a new version called closed space that we're going to have.
Now everybody's very hungry, I think.
Yeah. So let us thank the speakers one more time.